Problem number 2, we'll go ahead and we'll draw that out. So again, we draw a triangle. Okay, like that. And so now what we'll do is we'll go ahead and we'll put our alpha value. So we'll call this alpha. This guy, this angle will be beta, and this angle will be gamma. So our beta is equal to 30. Okay, and what we don't know is we don't know gamma. So we'll fill that in here. And so that's going to be equal to 180 degrees minus 30, which gives me 150 degrees, minus another 85, which is going to give me, I believe, 65 degrees. Okay, so now let's go ahead and fill some of the values in. Okay, so we can put in here for gamma 65. Now what we don't know are sides A, B, and C. So to solve the triangle, we need to get those. I shouldn't say we don't know all of those. We don't know A and B, but we are given the value for C. And C is 5.25. Okay, so what we're going to have to do is we're going to have to use one of the angles on the side lengths that we know. So that's going to be the gamma and the side length C. So what we have is that the sine of gamma, which is 65, divided by the length of gamma's opposite side, which is side C at 5.25. That's going to be equal to, now let's go ahead and let's grab A first. So that'll be equal to the sine of alpha over A, and we know that alpha is equal to 85 degrees. So solving for A gives us the following. It gives us 5.25 times the sine of 85 degrees divided by the sine of 65 degrees. So we'll grab our calculator. We'll just plug that in. So 5.25 times the sine of 85, and we'll divide that by the sine of 65. We'll get 5.771. Now let's think about that. Gamma was 65 and alpha was 85, so the side opposites of alpha should be longer than the side opposite gamma, which it is. So when you're working these problems, just make sure that you're checking, does the answer actually make sense? And this one looks pretty good. Now let's find B. Since B is the shortest side of the triangle, because it's opposite of the shortest angle, which is beta at 30 degrees, B should be the smallest, so it should be less than 5.25. So let's do that over here in green. Now I could use the 5.771 and the sine of 85. However, it's going to be more accurate if I use the sine of gamma, so the sine of 65 over 5.25 again. So that's going to be equal to B, and then the sine of 30 degrees. So when we solve, we get B is equal to 5.25 times the sine of 30 divided by the sine of 65. If you need to do this in a couple steps, by all means do it that way. So 5.25, well, that's no good. We're having calculator issues. So hopefully this doesn't cause a problem here. And it is. Let's restart the calculator. Oh, why not? Let's grab this calculator instead. We don't need the other one. And this one has less of a chance to error while we're creating videos. So what we want is 5.25. The only difference is we have to work in reverse here. So I'm going to have to go sine 30. I'm in degrees. So 30 sine gives me 0.5. So I'm going to have to take 5.25 times 0.5. And now I've got to take that guy and divide it by the sine of 65. Which is giving me we'll say 2.9. Okay, and so now we've got this for beta, which is 2.9, and that makes sense. It's definitely smaller than the other two sides. So now we've gotten all of our angles. Okay, here they all are. And we've gotten all of our sides. And so we've solved the triangle.